we can use some sort of mechanism to ensure compliance to whatever agreement or commitment we make. Yeah. So we make a promise, how to ensure that that promise is kept. Yeah. And look, Marcus, yeah, from the title, Marcus was talking about a reputation-based mechanism, and my talk is about institutional incentive. Teddy already talked about institutional punishment, but I'm also look at institutional reward. Yeah. And the scenario is slightly different. It's the multiplayer games. Teddy talked about Prisoner Dilemma, where an interaction occurs between two players. And in reality, you have many interactions that occur amongst a group of agents, more than two agents. Yeah. And this is collaboration with Lucas, and he cannot be here, so I'm going to give the talk. Okay, so a bit of motivations for why commitment can be a useful mechanism for enabling corporations, whether it is in two pairwise interactions or in multiplayer interactions. So I was thinking it would be good to just take some quotes from this is very interesting book collections by Randolph Nesses. He said in his book, commitment is giving up options to change incentives in the situations. Yeah. And individuals must consider that promises or threats may be fulfilled. If I make a promise that I punish you, I make a promise that I will reward your actions, then people have some reason to believe that I might actually fulfill that. And the key thing here is how you can ensure that your commitment, your promise, your threat is reliable. Yeah, that is the key for the success of a commitment mechanism to ensure commitment compliance. And we can see that in reality, cooperation is not just about trading incentives. It's not about like, if I help you, you help me. We usually engage in much more long-term commitment. So I don't really, sometimes even if you defect, yeah, I can easily forgive it if we are in a committed relationship. And the book hypothesized that the specialized capacity to make commitments may have evolved by natural selections, and lots of my work have been trying to build models to study this, to show this in a rigorous way, using methods from evolutionary game theory, which Teddy already talked in earlier. Yeah. Okay, so we have a lot of examples of commitment or agreement in the real world, especially the one that based on a bit more on the institutional mechanism. For example, in climate change, in collective hunting, and we see, for example, the agreement at the AI Safety Summit, like a few months ago in the UK. And if you are aware of this literature in multi-agent system, commitment-based mechanism have been used a lot to ensure reliable communications. So there's lots of formal works that develop commitment-based mechanism to ensure highly reliable communications in database, for example, or in many multi-agent systems. Okay, so how we define commitment formations? It can be, this is the simple way. Yeah. So before the interactions, before you do business together, players, assuming there's a third party who manage the agreement. Yeah, you can also do in terms of sorts of personal agreement, but before the interactions, the players in a group can say they accept or not to commit to cooperate, they promise to cooperate. And commitment can be formed or not. Yeah, so then players can make conditional decisions on whether the commitment has been formed or not. So they can either cooperate or defect if the commitment is formed or not formed. So this is a very important issues here. the decisions about whether a commitment should be formed based on the whatever the player said in the first step here. So here you can see that it's relevant to consider how many people, how many individuals in the group actually say, okay, we are going to commit to Cooperet, whether they actually honor the agreement later or not. So you can make some conditional decisions on whether you should form a commitment or not. Yeah. And in evolutionary game theory, you need to define what are the strategies. So from these 3 decision points, you can actually say, okay, there are 8 possible strategies depending on what the players decide to do at each of the step. For example, if you have here ACC, meaning that the player accept to commit to Cooperet and they cooperate regardless of whether the commitment is formed. Or they can say, okay, I accept and cooperate only if the commitment is formed, but I defect otherwise. That is the ACD strategies, which is actually the one that is key to the success of commitment formations and immersions. And on top of that, you also can define some institutional mechanism for that. You can use either you can reward those who comply and actually, yeah, so compliant means they accept, then they honor the agreement, or non-compliant behavior is those who accept the commitment but then defect. So here we say that it is not justifiable to just punish where, if, for example, if the players do not accept a commitment, it's not justifiable to punish them. Yeah. So it is actually very relevant to one of the issues that he mentions earlier, which is antisocial punishment, where you can punish whoever you like. So even you actually punish those who cooperate because you say, okay, those are the ones who likely punished me in the past. Yeah. And with this sort of pre-communications, you actually can avoid that issues of antisocial punishment or antisocial reward. It is not explored in this paper, but we actually also can consider that given the benefit that you can make a commitment, is it actually good to spend part of your budget to incentivize people to commit in the first place instead of just waiting until they commit, then make sure they comply. Yeah, so it's actually good to spend some incentive from your budget to encourage people to, for example, to come to a meeting instead of just let them make decisions on that. Okay, so some of the past work where we look at pairwise interactions so for example, in an earlier paper, we look at the prisoner dilemma like Teddy did in his work. And also in another paper, we study that commitment-based behavior and incentive can actually lead to some sort of interesting behavior where we look at the competition between different AI companies. They're racing for the dominations of certain in certain area, and we actually show that voluntary commitment can actually solve the issues of over-regulations. But in all these cases, we look at commitment between 2 players. So here, again, I mentioned earlier, it is really important to look at when commitment should be formed. And with 2 players game, it's natural to say that a commitment is formed if all parties commit. Yeah. But if you look at multiplayer games, if there are, let's say, 5 individuals in the group, then whether you actually need all of them to commit to form an agreement. So this work in this talk is focusing on the impact of this commitment threshold, the decisions when a commitment should be formed to get the optimal level of cooperations and commitment compliance. Yeah. And you can see lots of examples like this in climate change agreement, safety agreements. Usually an agreement can be formed if a threshold number of people say, yes, we are going to commit. That's enough to form the agreement. And the question is, what is that optimal threshold? Yeah. And because this is a multiplayer game, it's natural to use the public goods game. So in a public goods game, you have several players who can decide whether to contribute to the public goods, and their contributions is multiplied by a certain factor and share amongst all the players, regardless of whether they contributed in the first place. So here you can see a dilemma. Nobody would want to contribute, but collectively, it would be best if everybody contributes to the public goods. And we extend that with commitment formations. Yeah. Okay, so now before the game, all players can say, okay, whether they commit to cooperate, commit to contribute to the public goods or not. And a commitment is formed if the number of committers is greater than a threshold. It's a fixed number that is set by the institutions. Yeah. And here, as I mentioned, so this work has been published in a paper in Applied Mathematics and Computations. We asked the question, okay, whether institutional reward or institutional punishment is better at ensuring compliance, and how that each of the mechanism works in relations to the threshold set. Yeah. So here's just about to illustrate the setup of our experiments. We have lattice, square lattice, yeah, and at the beginning so you can see that there are 8 strategies as mentioned earlier. You randomly distribute them on the lattice, and then they play the game in neighborhood. Yeah, so you have 5-player game now because you have 1 player and 4 neighbors. And after they play, they gain some fitness. There's behavior update, so evolution happens where a randomly selected player would copy the behavior of someone else in the neighborhood with a probability proportional to the fitness difference. Yeah, so this is a very standard setup in evolutionary game theory on network. And we run it for long enough until we reach equilibrium. Yeah. Okay, so here are some observations. So we can see that commitment formations requires sufficient participation. So it's not good to just say, okay, out of 10, only 2 people say they are going to commit, to cooperate, to contribute. You shouldn't form an agreement then. Yeah. So you need a strict enough level of participations for commitment to be formed to ensure compliance as well as corporations. Then we now look at punishment, institutional punishments for varying this multiplication factor public goods contributions. Basically, it means that that is the multiplication factor that the contributions of everyone to the public goods is multiplied by before it distribute amongst all players, regardless of their initial contributions. Basically, the larger this multiplication factors, the easier the public goods game. Yeah, so it's easy to call for corporation to emerge if you have very high multiplication factor. So usually in the literatures, it look at this is 5-player game. So usually people look at like at most 3. Yeah. So you don't look at the public goods that is too easy to solve. For example, so here basically we want to see the area where R is less than 3. Yeah. And you can see that for small threshold, we don't have corporations through punishment and commitment. And one interesting observation is that you don't need the full participations in the commitment to reach some high level of corporations. For example, with T equal 3 and T equal 4, you already have some corporations, let's say 50, 60%, with a very minimal cost of incentive to the institutions. But if you want very, very high level corporations, let's say 90%, 100%, then you need very strict level of participations. Yeah. So this is just to demonstrate what I just mentioned. So an intermediate threshold is sufficient to ensure the survival of corporations, but it's not sufficient to ensure very high level corporations through punishment. For reward, the situation is a little bit different. Here, what we observe is not very sensitive to the threshold of the number of committers. So we see very similar results for all thresholds. And when combining, so comparing reward and punishment, what we observe is that reward is preferred to punishment for low threshold, while punishment is preferred to reward for high threshold, and when we want very high level of corporations. Yeah. So if you want just a bit of corporations, like 50, 60%, when corporations is already more abundant than defections, then it is good to just make an intermediate threshold, 3 out of 5, 4 out of 5. And in that case, it's actually very good that the institution doesn't need to spend a lot of budgets. Yeah. But if you want very high level corporations, yeah, then either reward or strong punishment is important. Yeah. I conclude now. Yeah. That is what I just said. Yeah. So punishment, intermediate threshold require low level punishment cost for corporation survival. And using reward is actually a good thing. You don't really need to worry too much about the threshold. Is not very sensitive to that. And you can consistently get some reasonable level of corporations. So just quick words on future works. We have done this for this public goods game and had mentioned some applications like climate change agreement and agreement about AI safety. We actually have some nice games that you can easily transfer this model to that to study whether commitment-based mechanism can be used to decrease like climate change agreement that like non-compliance. And here we only focus on this sort of very simple network structure, which is lattice. Teddy already showing his work, like heterogeneous network, like scale-free network could be interesting to lead to some more sorts of non-linear behavior. Okay, that's it. Thank you.